Hey everyone, this video is going to be the first video in our new YouTube playlist for programming tutorials. Now, I'm really excited about this playlist because we're going to be able to launch a bunch of different videos and tutorials that allow people learning to code to follow along and build up their portfolio and build different projects, as well as see how different programming constructs are used in real projects. So this first project that we're going to be doing is going to be a little more simple. It's just going to be a console game written in JavaScript. It's a Battleship game, right, where you try to sync their ships and the computer tries to sync your ships. But in the future, we're going to have tutorials that range from, as simple as this to full stack applications, fully developed. So stay tuned to see what type of tutorials we have, and hopefully as you follow through them, you'll become a better developer. So to start, like I said, this is going to be a JavaScript tutorial. We're only going to be using the console here. So the only piece of HTML that we're going to use at all is just to link our JavaScript file up to the browser so we can open it in the browser and see the console. We're going to be using Chrome here. So I'm going to go ahead and start by creating a file, and I'll make this my index.js. This is where we're going to write the bulk of our code, actually all of our code. And what we're going to do here is we're creating Battleship, which means we need some kind of grid-based system, right? We need to be able to choose the coordinates to put our ships in, and we need to be able to choose the coordinates that we're going to fire at and attack and try to guess where the computer opponent puts his or her ships in. Now, for the sake of this, we're just going to have single space ships. We're not going to have longer ships. Everyone's only going to take up one space. And so you're going to put your ships on the grid spaces that you choose. The computer's going to randomly put its ships on coordinates, and then you try to guess where they are, and whichever one guesses first wins. So to start, we're going to go ahead and initialize all of our variables. And when I say all of our variables, I mean just the core variables that are going to be used in this game. And so let's make the game a little dynamic. We don't want the grid to be the same size every time. Let's say we can choose what size we want the grid, and we're going to even choose what side we want our grid to be versus the computer's. Maybe if we want to challenge, the computer's grid can be larger and ours can be smaller. So that'll make it a little more dynamic. So let's start by creating two variables to capture those grid sizes. So for our grid size, we're going to go ahead and get this from some user input, and we'll say, what size would you like your grid to be? Right, and this will make a little pop-up box show up in the browser, and the user is going to be able to input a number, any text, but we want a number for this, and we'll save that number in my grid size. And we'll do the same thing for, we'll use enemy instead of opponent because it's easier to type. Go ahead and copy this. What size would you like your enemy's grid to be? We'll just say enemy grid. There we go. Now we're going to go ahead and write a function that allows us to create a grid. Now this grid is going to be spaces, it's got columns and rows. So to do that in JavaScript, we're going to use an array of arrays. We don't have access to a multi-dimensional array in JavaScript, so we need an array of arrays to do this. So we'll go ahead and create a function called createGrid. And this is going to take one parameter size. What we're going to do is we're going to create an array here, and then based on the size, we're going to create that many more arrays inside the array. So each element in this original array here, grid, is going to be an array itself. And then that's going to allow us to have a grid-like data structure, because we can identify the X or Y coordinate based on the element in this grid, and then we can choose the opposite coordinate based on the element in the interior array. So we'll say for let I equal 0, while I is less than whatever the size that we get passed in, I++. And then inside here, we're going to go ahead and say grid I is equal to a new array, right? So we're going to put an array inside of our grid array for each count until we're up to size. Then what we're going to go ahead and do is inside that array, j is less than the size, j++, we're going to make all of our grids be equal. It's going to be 5 by 5 or 12 by 12 or 3 by 3, no 5 by 8s or anything like that. So that's why we're going to use size for the outer loop and the inner loop here. What we're going to do is we're going to set each position in our grid to a default character that's going to show when that position is blank. So we're going to say grid I j equals, we'll just use a dash. So what that means is every position to start on our grid is just going to be a dash. And then when we place our ships on the grid, we'll put a character there. And then when we've attacked a space on our enemy's grid, we'll put a different character there for a miss or a hit. So this enables us to create our grid. At the end, we need to go ahead and return that grid. So now that we've got that created, let's initialize a couple more variables up here using that. We're going to say let my grid equal create grid, and we're going to pass that variable my grid size up there at the top into here, right? So we got this from the user input from prompt, and then we're going to create the grid based on that. We'll do the same thing for the enemy grid. So let enemy grid equal create grid. Make sure I don't have an extra E up here. Create grid, and we're going to pass in the enemy grid size. There we go. Now, to see what this looks like, let's go ahead and write a method that prints out the grid so we can, make sure this is actually working. So I'm going to go ahead and create a function called print grid. What this is going to do, we're going to pass a grid into it, and then we're also going to pass in a Boolean parameter called isEnemy. Now, isEnemy is going to tell us if we're looking at our grid or our enemy's grid, because if we're looking at our grid, we want to know where our ships are that we placed. That's okay. But we can't see our enemy's grid, so we don't want to be able to see where their ships are. So we're going to use this parameter to enable us to look at both grids using the same function, but differentiate between what we should be able to see as the player and what we shouldn't be able to. So what we're going to do is we're going to set this to false by default, and then we'll write the rest of this function here. So we're going to go ahead, we're going to create some headers, and the headers, that's going to be the numbers that make up the coordinates across the x-axis, so that we can see, oh, this is column 0, this is column 1, 2, 3. So we're going to say headers equals, and then we're going to write a different method called create headers instead of storing the logic to do this in here. What we're going to do is we're going to pass in the grid.length, and then we'll come down here and we'll create this other function. Let's see what we got going on here. We'll come back to that. So function create headers, that's going to take a parameter size, and then we're just going to create a result that we can turn back, a string, let result equal, and then we'll put a few spaces in there, 1, 2, 3, maybe 2. We'll put 2 spaces in there to start, and I'll show you why once we print it out. So we're going to say for let I equals 0 while I is less than size I++, and then we're going to go ahead and say result is, we're going to concatenate I plus a space so that it's just a little more even when we're printing it out. It's not all scrunched up together. Then we'll return that result. So if we pass in, if the grid is size 10, we're going to have headers across the top saying 0 through 9, which will be very helpful. So we're going to come in here. There's my issue. This is spelled incorrectly. Function. So we're going to come in here. We've got the headers. Now we need to print out the rest of the row, the grid. So we're going to say console.log. We're going to print out headers. And then we're going to say for let I equals 0, while I is less than grid.length, to iterate through the length of our outermost grid array, I++. And then in here, we're going to go ahead and we're going to build up each row as a string. So we're going to create a variable called rowString, and we're going to set that equal to whatever I currently is plus a space. And then we're going to have another loop in here. So we're going to say for let space of grid I. So we're going to take a look at each space in this current array, the inner array here. So grid I. If is enemy. So if it is an enemy and the space is equal to, we're going to use a capital O for a ship to be placed. So if it's the enemy and the space is equal is one of their ships, we don't want to be able to see that ship when it's printed. So we're going to go ahead and concatenate one of the what looks like blank spaces. We haven't shot at this space yet. Otherwise, if it's not an enemy, or if it's a if it is an enemy but their ship's not there, then we'll just go ahead and say we're going to print out whatever is there already, which would happen to be a dash if it's just a dash. So we'll say the row string is going to be concatenated. We're going to concatenate the space to the row string plus an extra blank space. And when I say space, this variable, see it says let space of grid I, that's each cell in the grid. So cell could actually be a better name here. So we'll say for each cell in this row on our grid. And then we're going to go ahead and come outside of that loop, and we're going to say console.log rowString. And that should print it all out. So what we're going to do now here, we've created two grids. Let's go ahead and print the grids and see what they look like. So we'll say print grid. We're going to pass in the enemy grid. We'll print their grid first, so it will be on top, kind of as if we were playing Battleship. We've got ours closest to us and theirs furthest from us. So the enemy grid, and then we're going to pass in true for the isEnemy parameter. And then we're going to print grid for our grid, and we're going to just say my grid. We don't have to pass anything because the isEnemy parameter is false by default. So we'll save this. And now I can't just open this in my browser. I need to go ahead and create an HTML file. So we'll do that, and I'll put some HTML in here. And you don't have to type all this out. You just have to have the basic pieces of HTML. I'll put a title here. I'll call this Battleship. And then in our body, we'll add a script. And the source for that script is going to be our index.js we just created. So now I can open this file in my browser. And again, if you're using a different editor, you just have to open your HTML file however you normally would. And I'll open up the console. Actually, we'll start here. What size do we want our grid to be? Say 3. What size do you want enemies to be? Let's say 5. And there we go. So the top one is our enemies grid. The bottom one is our grid. And we've got the headers and the rows all printed out there. So we're able to start with these grids created. Now we'll add the stuff to place our ships, the code to place our ships, and then the code to be able to attack. So let's go ahead and do this. We'll minimize this, come back to our code here, and let's initialize a few more variables that we're going to use to keep track of the gameplay. So to start, we're going to go ahead and create basically like lives. We're going to create my ships, set that equal to 3 because we'll be using 3 ships, and then we'll say let enemy ships equal 3 as well. So what we're going to use is these variables, we're going to decrement them anytime we actually hit an enemy ship or we get our ship hit by the computer player. And once one of them reaches 0, then the game's over, and whichever one is greater wins the game. So let's go ahead and program out functions of how to place our characters. We want to be able to place a ship, so we want to be able to place those O's that we're going to use on our grid. So we'll go ahead and create a loop to do that. We're going to be placing 3 ships. So let's go ahead and say we'll say let I equal, we're going to use 1 because instead of 0, which we would normally use, we're going to use 1 because I want to use this in the prompt that is going to prompt the user for the coordinates to place the ship at. And the reason I want to use it in the prompt is I want to say enter the coordinate for ship number 1, 2, and 3 instead of 0, 1, and 2. So we'll go ahead and say while I is less than 4, that will give us 3 iterations of this loop, I++. And we'll go ahead and create some local variables here in the scope of this for loop. We'll say let x equal prompt. Say enter the x coordinate for your ship number. And we'll concatenate I right there. We'll go ahead and copy this. And say let y equal enter the y coordinate for that ship number. Then we're going to create another function here called place character. And place character is going to allow us to place a character at the x and y position that we just got from our user input. And what character are we going to place? We're going to place a capital O, meaning that's our ship. And then we need to know what grid to place that character on. So we're going to go ahead and say my grid. Now, place character doesn't exist yet, but we're going to go ahead and write that function down here. So we're going to say function create character, or place character is going to take x, y, c, c is the character, and a grid. So with that, we are going to say where we want to place that character at on our grid, which is actually a very easy one-liner. We can just say grid. We say y first because backspace, y and then x, because y is actually the outer array, which is going to be the first part of it, and x goes across the top. So those are the cells within the nested arrays. And we're going to say equals c. So we're going to put the character on the grid at that coordinate. So we can test this out real quick. Let's come back in here. We print these out before. Let's print them out again after this loop and see what it looks like. And actually, we can even, let's print them out in each iteration of this loop so we can see what they look like after we place each character. So save this. Open this up and refresh our browser. And let's make them both size 3. Now it says, where do we want to place our ship number 1 at? So I'll go ahead and let's place it at 1, 1, right in the middle. So x coordinate is 1, y coordinate is 1. And we print it out. We can see our ship was placed right there, which is nice. Let's go ahead and place another one. Let's place it at 0, 0. There we go. We've got both of our ships placed right down here. 1, 1, 0, 0. Let's do 2, 0 right there in the upper right hand corner. So we'll say 2 is the x coordinate, 0 is the y coordinate. And there we go. We see our ship was placed right there. Now I've got this 3 showing up. I'm going to go ahead and try to figure out why that's showing up. So let's see. We've got our print grid here. Create grid. There we go. Looks like it's showing up right there. Do I have a print somewhere out here? Let's see. On my console. No, they're just right there. Row string. Row equal I. Interesting. Well, we're going to ignore that for now. We're going to keep moving. So let's go ahead and we are able to place our characters, our ships on the grid now, we need to go ahead and make it possible for the computer player to randomly place their ships on the grid as well. And we want them to only be placed within the grid itself, the size of the grid. So what we're going to do is we're going to add another method call here to something that doesn't exist yet. So we're going to say place random character. And it's going to be very similar. It's going to take, instead of X and Y, because that's going to be randomly generated, we just need to take the character that needs to be placed. So that's going to be the capital O. And then what grid, this is going to be on the enemy grid. And then we need a max size. What is the range of the grid so that we know not to go outside of that? Well, we could derive that from enemy grid, but we're going to just pass in the enemy grid size that we've already captured there. So enemy grid size. And then we'll come down and we will write that function. So we've got place character. We need place random character. So function place random character. This is going to take the character, the grid, and the max size. Now we're going to go ahead, and what we don't want to happen is we don't want to have our computer player place a ship in the same place it's already placed a ship. So in order to do that, we need to create a Boolean variable here that will set to false, and it's going to say did place. What we're going to do is we're going to iterate over and over again until the random coordinates have been chosen that are different from other previous random coordinates, just so we don't happen to have two ships on the exact same spot, because that would break our game. So we're going to say while did place is not true, right, which it's not to start, we're going to do the same thing over and over again. We're going to say let x equal get random int, which is a function we're about to create, and let y equal get random int, passing the max for both of those. And before we go any further, let's go ahead and create get random int. So function get random int is going to take a max value, and it's just going to be a one-liner. We're going to go ahead and return math.floor math.random times math.floor max. And what that's going to do is give us a random integer between 0 and the max non-inclusive. So if we pass in 3, we're going to get either 0, 1, or 2, which works perfectly with our grid. Because of a grid size 3, 2 is the last element in it. So that's perfect. So we've got that coded. Now we're going to say if, this is where we need to create another variable up at the top to keep track of the places that have already been placed. So we're going to say if enemy locations, this is going to be an object, and then we're going to go ahead and take those x and y coordinates and make a string out of them to represent that position. So we can look back at this object and see, does that position exist? If it does exist, then we've already placed something there. So we need to continue trying to find a different random cell or position to place the character on. So we're going to go ahead and say, we'll use a template literal here. This is perfect for it. We're going to put x in there, dash y. So we're going to check to see if the object enemy location, which we are going to create up top here in just a second, has a property that equals our x dash y. So if x was 2 and y was 1, we're going to check for a 2 dash 1. And if that does exist, then we know we've already placed something there, and we need to continue to find another random set of coordinates. If it doesn't exist, then we can go ahead and place something there. So we'll say place character x, y, c, and grid, which is really nice because we're just using a function we've already created. Then we're going to set did place equal to true, so we stop iterating in this while loop. And then we're going to go ahead and create this property on this object we're about to create, set that equal to true. That way, if we ever get this same x and y again, it will not allow the computer player to put another ship on that space. So let's go ahead and create enemy locations up here at the top with our other variables, and that's just going to be an empty object to start with. All right. So this should enable our computer to randomly generate his or its 3 ships. Now, if we run this, we won't be able to see it because if it is an enemy, we're going to not show the ship because we shouldn't be able to see their grid, right? So we could either change up this logic right now and test it and see where the enemy puts their ship, which is a good thing that we could do, or we can just move on and work on the firing, to the launching an attack at a specific coordinate to see if the enemy has placed a ship in that space. So that's what we're going to do instead. So we're going to go ahead and build an attack function. So what the attack function is going to do, just like it sounds, it's going to take the coordinates and it's going to take a grid, and it's going to determine if the attack was a hit or a miss. So function attack takes an x, a y, and a grid. And we're going to say if the grid y, if the grid at yx, if that position is equal to a ship, then we're going to go ahead and use exclamation points to denote that it was a hit. So we're going to change it from the O to an exclamation point. Save that real quick. And then we're going to return true because we're going to use, we're going to say that the attack function returns a Boolean to tell if it was hit or not, which we can use later then to decrement our lives, my ships or enemy ships, depending on if they hit us or we hit them. Now we're going to go ahead and say else if the grid, or the grid at yx, or the position we attacked, is equal to just a random blank spot, then we want to show that we've already attacked that position. So we're going to set that to an x, just a lowercase x. There we go. We need to change this. It needs to be 1 equal. It needs to be an assignment operator, not a equality operator. All right. So we'll set it equal to an x, and we'll return false because nothing was hit, right? It was a miss. Otherwise, meaning the reason we have this last condition is because if it's not an O and it's not a dash, that means it could accidentally be the same spot we've already hit before, and we don't want to, or it could be this or this, any spot that we've already shot at before, and we don't want anything to happen. We don't want to change it or overwrite the value. Because if it was this and we didn't put anything here, then, and this was just an else, we would overwrite the exclamation point with an X, which we don't want. So we're going to just go ahead and return false here and say nothing changed. We're not going to change anything. We've hit a space that's already been hit, and return false. No new ship has been hit. All right. So we've got that. Now we should be able to, let's see, let's use that function in our gameplay up here, our loop. So that's actually where we place everything. So we're going to create another loop. I apologize. We're going to create another loop that is actually our gameplay. So we'll go ahead and create a while loop. And in this while loop, we want the game to play as long as we still have ships and our enemy still has ships. Because as soon as one of us doesn't have ships left, the game's over. So we'll say while the enemy ships is greater than 0 and our ship, so my ship, is greater than 0, we want to continue playing the game. So this will be our game loop right here. And this will be our game setup loop, right? All right. So while we're actually playing, let's create another local x and y variable. We're going to say x is equal to prompt, enter the x coordinate for your attack. We'll do the same thing for y. Enter the y coordinate for your attack. And then this is where we're going to use our attack function. So if attack xy that we just got from the user, we'll pass in the enemy grid. So if we attack them and it's a hit, we'll say enemy ships minus minus. We'll decrement that by 1. So let's start with this and see what we've got. We're placing our characters. They're going to place a random character. We'll print out the grids, and then we'll loop. So the enemy's not attacking us right now, so this should be a pretty easy game. Let's see what it's like. So let's exit out of this and open it again. Here we go. All right, let's just make both of our grids size 3. And let me see if I can. There we go. All right. Enter the x coordinate for ship number 1. I'm going to do 0, 0. And then we're going to do, let's do 1, 1, and 2, 2. We'll just go diagonally. And we're not getting our printing here. So let's cancel this and make sure we saved here. Everything should be saved. Come back, refresh. Let's open the console first. There we go. We'll refresh it. Let's make our grids 3 and 3. There we go. We got the stuff printing. So we're going to put our first ship at 0, 0, our next one at 1, 1, and our last one at 2, 2. We can see our ships all there diagonally across the, from the upper left hand to the bottom right hand. Now we're going to enter the coordinate for our first attack. Let's try right in the middle. Let's start with 1, 1. And let's try 1, 2. And we can see that something is not working correctly. And let's take a look back. I think that's because we forgot to print out our grids after each attack. So let's go ahead and grab these here. And after the attack, we'll print out the grids so we can see the new, the updated grids. So we're going to go here, we'll refresh this, make our grids 3 by 3, put one here, another one right in the middle, and another one right there. Now we've got them all the way across. Now we're going to attack. Let's start with right in the middle, 1, 1. And we can see that we attacked and it's an X, so it's a miss. We didn't hit a ship. So let's try 0, 0. See if, put one there. Again, that's a miss. And let's try 2, 2. Oh, they were thinking like us. They put one on 2, 2. They're not attacking us, so we're going to win, which is awesome. But to make the game more fun, we're going to have to build it in so that they can attack us as well. Let's go ahead and jump back to the code here, because we don't have anything programmed once we beat them to say, we won. So we'll have to add that. But let's actually focus on the enemy's attack. So we can reuse X and Y. And the cool thing is we already have that get random int method or function created. So we're going to use that. We're going to say X equals get random int. We're going to pass in my grid size, right? Because it has to be, the max size has to be the size of our grid because that's the grid they're attacking. And then Y equals get random int my grid size. Then we can go ahead and say if, what we want to do is we need to check the attack just like in our if statement above, right? This time it's on my grid instead of the enemy grid. And if they hit us, we're going to say my ships minus minus. However, we need to add one more Boolean piece of data to this conditional, and that is if our enemy ships, spell it capital S, enemy ships is still greater than 0. Because what we don't want to happen is if we attack and we hit right here and that was their last ship, we don't want them to attack again, right? So we're going to check to make sure that they're still actually in the game before they can attack again. And then if they are in the game and they attack and they hit, then we're going to set my ships back 1. So that's basically it for the gameplay right here. Something else that I noticed is it's really kind of hard to tell which, I mean, obviously we're looking at the 2 bottom grids, but I like to have some kind of break in between to see the new update, right? We can't just clear the console here in the Chrome browser, but what we can do is we could print out a line of dashes between each set of 2 grids, our grid and the enemy grid. So let's go ahead and do that. We're going to jump back into our code and we're going to write another function here, and we'll call it draw break. So it's going to draw a break in the console. And that's just going to console.log out that. There we go. So now we can draw a break anywhere after we print out, or before we print out another set of the grids. So we print out the grids right here. We can go in here and add a draw break. So draw break right there. And then we can say before we print out anything here, let's draw a break as well. All right, so that'll make it just a little more visually appealing and easier to see what's going on. The next thing that we need to add is we need to know who won, right? So if our ships, my ships, is equal to 0, then we lost. If enemy ships is equal to 0, then we won. So that happens, this loop will break. We will be outside of this loop once one of ours is equal to 0 or no longer greater than 0. So what we can do is right outside of our loop, we'll come here and we'll say if my ships is less than enemy ships, right? We know one of them equals 0 at this point, but which one is it? We'll go ahead and say lose it all. Otherwise, we won. So we'll go ahead and say victory. All right, so let's see if we're missing anything here. We're going to jump in this and cancel out of that, refresh, and let's give this a shot. So grid size of 3, and we'll do the same thing. We're going to put 1 in the bottom right-hand corner, 1 right in the middle, and 1 in the upper left-hand corner. All right, and you can see our break there, so we can clearly see where the break between the old set of grids is and our new grid. So now we can enter the coordinates for our first attack. Let's hit right in the middle, and we missed. Let's go 1, 2. Oh, we got a hit, and it looks like they're destroying us right now. They've hit 2 of our ships already. We've hit 1 of their ships. So let's see what happens here. We'll go 0, 0. Oh, we hit 1 of their ships. It's tied up and they missed, right? They hit us right here. We hit them. Let's go 2, 0. And we both missed again. Let's go 1, 0. Both missed again. Let's go 0, 2. Missed again. And if we ever see, there's a possibility because of the randomness that the computer will hit in the same spot it's hit before, right? So we've hit 1, 2, 3, 4, 5, 6. The computer's hit 1, 2, 3, 4, 5, 6. So it looks like they have hit every time, chosen a different one. So let's go ahead and see. Let's hit 2, 2. See what happens. 2, 2. We missed. All right, at this point, we've hit 7. They've still hit 6. So they shot at one of the same spots again. If they want to do that, that's fine. We could obviously program a way to keep track of where they've hit before, the same way we've kept track of where they placed their ships. But we're not going to do that for the scope of this tutorial. So let's go ahead. We've got 2 more spots we can choose. Let's go with 0, 1. 0, 1. And we can see 0, 1 was the last one. We hit it. So we win and we have victory. So that's it for this simple game of Battleship in JavaScript. Hopefully you had fun learning and building something from it and can grow as a developer. Good luck.